out now to someone else who's actually big on components, and that is Bruno Fierens from TMS Software. TMS are a tech partner as well, and they also produce components. Ray does a lot of components, but TMS do an overwhelming amount of components. And this session is, I actually personally asked for this session because I'm a fan of the Raspberry Pi. And this session is about building apps for the Raspberry Pi from Delphi, from TMS Software and Bruno Fierens. We'll speak to you afterwards, where Bruno will be joining us for live Q&A.
Hello everyone and welcome. I'm Bruno Fierens. I'm working for TMS Software and I welcome you to this webinar all about using Object Pascal, using Delphi to create applications that will run on a Raspberry Pi. And we will do this via our Miletus technology. So in this webinar I will present you what a Miletus app is, how the architecture is of such a Miletus application. I'll take you step by step how you can create such a Miletus application from the Delphi IDE, and finally also deploy it on a Raspberry Pi device. With this Miletus technology, you can not only develop applications for Raspberry Pi from the Delphi IDE, you can also create cross-platform desktop applications. So we will also have a look at what's different between creating regular desktop applications with Miletus versus creating them for Raspberry Pi. We will also bring FNC in the mix later on in this webinar, more about what FNC is, how it is architected, what you can do with it. And we will conclude this webinar by showing you a demo that uses a Delphi application deployed on a Raspberry Pi and that works with electronic sensors connected to the Raspberry Pi. First of all, what is a Miletus application? A Miletus application is a native application that runs on desktop operating systems, but also of course on the Raspberry Pi. And these desktop applications host an embedded browser. The actual application, the code that you write, runs within this embedded browser. And of course, with the limitation of running in an embedded browser, you cannot do everything you want in a native desktop application, so there is the need to have a bridge that performs bidirectional communication between the application running in your browser and the operating system. And of course, this application not only consists of code that is running in the browser, but also most likely several resources. I'm thinking about images and other UI elements that you might need, and all these resources are also embedded into this native application. And as you can see, this solution is integrated and can be used directly out of the Delphi IDE, but also from Lazarus IDE and the Visual Studio Code IDE. You could not, of course, ask yourself the question, why would we go to do the effort to create an application this way? There are several pros and cons, and so let me highlight a couple of pros for choosing this approach for creating a cross-platform native application. First of all, is that when we create such an application in Object Pascal, we can reuse our code for creating this type of cross-platform desktop applications, and we can also reuse code that we might have used for web applications created with TMS WEB Core. TMS WEB Core, which is our framework, and using the technology of the PAS2JS transpiler to transpile Object Pascal into JavaScript running in the browser. And you might have done developments to create such a web applications with Miletus you can reuse this existing code to create native applications directly running on the operating system, so not running from code that is hosted on a web server. In terms of creating the user interface, where typically we have been used to creating the user interfaces with the VCL framework, and later on for cross-platform with the FMX framework. Here, in this case, we can use all the advantages that come with HTML5 and CSS3 to create really nice, attractive, beautiful user interfaces. And with that, we can also reuse a wealth of existing web frameworks, web CSS libraries, etc., to create such a nice user interface, or even other web libraries for specific functionality. Of course, cross-platform, we are familiar with it through the FireMonkey framework. Also here with Miletus, we can use one code base to create applications for 4 operating systems, in this case Windows, Mac OS, Linux, and here for this presentation we will focus on the Raspberry Pi. You might want to run this application, this cross-platform application, locally on an operating system, but also use cloud services, for example, to interact with things on the web, in the cloud. And as this runs in the browser, this means that it is also easy, straightforward to create applications that also interact with cloud services, for example. Or you might even host a part of the application as being served from a web server and the other parts of the application running locally and native on the operating system. And finally, also something specific in Miletus is the ability to use local databases and use the standard approach that we have in Delphi applications with the data source and the data set connected to DB-aware controls, to use that approach to create applications that will work together with a local database. If we look at how Miletus works, how it is architected, it is, as I mentioned, architected using an embedded browser in which your application runs. And looking at that embedded browser, here is an overview of what the browser is in each of these cases. So on the Windows operating system, we have the Edge Chromium browser. On the Mac OS, we use the natively available Safari browser. On Linux, this is the WebKit browser, and the same applies to Raspberry Pi, where also WebKit is the default browser. In a nutshell, this means that there is no separate browser engine to install. So in terms of deployment, you do not have to redeploy a browser engine together with your application. Miletus is simply using what is available, what comes with the operating system. And so technically, how do we create such a Miletus application? So remember that I mentioned that the actual application is running in a browser. So therefore, the native language of a browser is the JavaScript language. Therefore, the first step is compiling or transpiling Object Pascal code to JavaScript. This is being done with the Past2JS transpiler, which is a transpiler that is created by the people of the FPC team. For the user interface, it is running in the browser, so it's kind of normal that the user interface is built up out of HTML and CSS3. This HTML CSS combined with the JavaScript generated from Object Pascal is actually what will be running in the browser, and this together is packaged in a native application as a resource, and this native application will launch this JavaScript, HTML, CSS in the embedded browser. In addition to that, there are several classes and components that are being used that make it easy to interface with the operating system from your Miletus application. What is meant with that is, I give an example. If you want to open a file, you could use the operating system open file dialog to pick the file that you want. Here we are launching the actual native operating system open file dialog. And it is launched from the embedded browser where your application is running. And so we offer lots of classes that allow you to do this with open and save dialogues, but many other operating system functions are exposed via these classes and components, so that out of this application running in an embedded browser, you have actual direct access to operating system functionality. In terms of how this is available to you as a Delphi developer, we have integrated this entire workflow into the Delphi IDE. That means that if you have the Delphi IDE, have TMS WEB Core installed, because Miletus is actually a sub-part of TMS WEB Core. If you have that installed, when you create a new WEB Core application, you can choose from the several types that are available. You can choose to create a TMS Web Miletus application. And if you have opened such a Miletus project, you will find forms, components that you can drop on the form. So it's a RED component-based approach to creating such applications. And basically you compile directly out of the Delphi IDE the application that you have created, just like you would do actually with a VCL or a FireMonkey application. Now, a brief overview of several classes and components that are available to allow you to directly interface with the operating system. Here is a brief overview. We have two types of classes that allow you to have direct local file access, which is the Miletus string list that lets you open and save text files directly on the file system of the operating system, which of course standard in a browser is not possible, obviously, for security reasons. And the same applies for accessing binary data, which you can do with the Miletus binary data stream. Interaction with the clipboard, operating system clipboard, is also possible with the Miletus clipboard component. Shell functions can be executed with the Miletus shell component. Getting typical operating system paths is also directly supported via an API function. You can also interact with files that you drag into your application or to drag something out of your application. Also, that is possible. I mentioned earlier on directly using operating system dialogues for opening files, saving files. The message boxes are also the real operating system message boxes. So these will be the message boxes as you are familiar with on Windows, but also on Mac and Linux. These are all triggered from your application running in the embedded browser, but actual native dialogues. Also menus. So in Windows applications have the typical Windows menu, but the same applies for a Mac OS application, where the difference is that in the Mac OS the application menu is on top of the screen, where in Windows it is integrated within your form client area. The message here is that with the Miletus main menu, with which you interact just like you would do in a VCL application with the main menu, you get direct access to the operating system defined menu in your application. And it will look, feel, it will not only look and feel, but actually it is the native menu that you deal with directly out of the code of your application running as a Miletus application in that embedded browser. And the same applies for a pop-up menu. Also, toast messages, which are now a standard part of the operating system, can be directly launched from your Miletus application. When we talk about multi-form applications, so having multiple forms in your applications, this is somewhat different from, let's say, VCL or FireMonkey applications, because this means that we need to provide a method to do the communication between different forms. And this is because if you have different forms, this means that in these forms you will need an embedded browser that runs part of your application in that embedded browser. And so you need a way to communicate from browser to browser, because if form 1 is using an embedded browser, form 2 is also using an embedded browser, at some point you might want to communicate between these two forms. And so for this we have offered the Miletus window component, and that allows you to perform this communication between forms, and so underlying communication between embedded browser. Some more components that allow operating system interaction are the Miletus tray icon, allows you to specify your application tray icon and send messages to it. A file watcher that that triggers events when some files are being changed in the file system. And finally, also shortcuts, global shortcuts, so you can assign your own operating system-wide keyboard shortcuts to specific functionality in your Miletus application. So how you would create and select the target for your Miletus application. This is done from the project manager in the Delphi IDE. Just like you have a FireMonkey application where you can also specify and configure for which operating system target you want to compile. Here we have integrated this into the build configurations of your Miletus application. And as you can see here on the screen, it offers Win32 64, Linux 64, Mac OS for Intel and for ARM. You can build for Raspberry Pi, and you can build in both in release modes and debug modes. If you want to deploy a Miletus application to the target operating system, or more specifically to the Raspberry Pi for this webinar, this is done simply by Xcopy deployment. So from the Delphi IDE, Miletus generates an executable file and a desktop shortcut file, and simply Xcopying these files to Raspberry Pi allows you to launch this application you created from your Raspberry Pi. And as you can see here, this is the project folder on one side, where you have your Miletus project, the source code, and you see in the output folder, you see the generated executable and the shortcut file for it. Let's first have a look at how Miletus is integrated in the Delphi IDE, and how you can create your first Miletus application directly from Delphi. So here we are in the Delphi IDE, Delphi 11, and let's see how we will create our first Miletus application. So WEB Core is installed. You can see this from the help menu. About TMS WEB Core is visible. That means I have WEB Core integrated. That means I can select under project types, the different TMS WEB Core projects, and of course in this session we will create a Miletus application. We get a form, we get our project in the project manager, so everything is pretty much the same as we have in a VCL or a FireMonkey application. So what I will do first is save my project, and let's call this project demo 1, and let's save the files to this folder. And now what I will do something to take advantage on soon, but not in the first place. Let's quickly drop some components on it. I have an edit control. The framework that is used within Miletus is TMS WEB Core. That's why I'm picking the TMS WEB Core components to create our first simple application. And so, okay, this is what we have, and we will add a very simple line of code. The typical example that we have done many times in VCL, in FireMonkey, we repeat it here for Miletus. Standard. This is configured in debug mode, and this will generate a Windows application. So let's compile and run this application. And here we are. This is the application that we expected, and if we click the button, items are added to the list box. We see here a menu, and this is the menu that appears by default because we have compiled our application in debug mode. As I explained, our application actually consists of Object Pascal code transpiled to JavaScript running in an embedded browser. When we want to debug our application, we will typically do this from the browser debugger. And so here we can see the source code and step through the code, etc. In this application. So that is why this menu is by default available when you are running in debug mode. So what I wanted to show you is immediately also how you can take advantage of web technology when you chose this Miletus approach. Maybe it's also good to have a look at the files that are being generated, so that you can see that you have actually a Windows executable generated, and that we can actually launch this standalone executable directly from the operating system. So I go to the project that I created, demo 1, and we go to the output folder, and here you can see the executable that was generated. You can see here that this is a 10 megabyte executable. When I launch it, this is the application I get. And so now let's introduce how we can actually very easily already take advantage of web technology. When I first created this application, I mentioned, okay, well, we'll already preset the setting CSS library to Bootstrap. And that means that our controls that I dropped on the form have already been preset with the Bootstrap, with the recommended Bootstrap class names to give our controls a nicer, more modern looking on this form. We only need to activate Bootstrap at application level, and this is something that we can do here with the options of the project, where we can manage the JavaScript libraries to be used with this application. And so here I will switch on the latest version, Bootstrap 5.2.3. So with that, Bootstrap is applied. Let's have a look what the difference is. Of course, I need to recompile my application before this to take effect. And now you can see how the look and feel of this application already changed by taking advantage of Bootstrap. And with this, you can see how easy it is to give your application a nice look and feel based on HTML5, CSS3, and applying existing web frameworks, CSS frameworks. You can also, at the same time, also apply HTML templates, for example. Many websites offer these templates, many of them free, and with this have a nice modern looking user interface. So now that we have covered the basics to create a Miletus cross-platform native application, let's bring FNC in the mix. So first of all, what is FNC? FNC stands for Framework Neutral Components, and that actually means that with one code base we can create user interface controls, but also non-visual components, for example, for REST API access and so much more, and that we from one code base can use these components and classes to use them on different frameworks for different targets. And these frameworks include by now the VCL framework, the FireMonkey framework, the LCL framework, which is the framework from Lazarus, but also the TMS WEB Core framework to create classic web applications, but also here for this presentation to create Miletus applications. Advantages of this approach is, first of all, that there is only one learning curve. So if you have mastered these FNC components once, whatever project lands on your desk, you can reuse what you learned with the FNC components and start right away creating the application that your customer is asking for. Of course, another advantage is that there is only one license needed for the components you can use. You can freely choose where, in what framework, for what target you will use these components. And so the targets include by now Windows, macOS, iOS, Android, Linux, the Raspbian or Raspberry Pi operating system, and of course browsers. All modern browsers are supported. How or what is the FNC framework and how is it architected? We have accomplished this by creating an abstraction layer. And so the abstraction layer sits between the component and the underlying framework. Frameworks being the VCL framework, FMX framework, LCL and WebCore framework. As we code against this abstraction layer, that means that if we write this code once, this code will run in all these different circumstances. And since we started with developing this FNC architecture, we actually started this development back in 2016. Since we started this development, we have a wide range of components developed this way, and we would categorize them into 4 different categories: non-visual components, a lot of user interface components, also components for accessing all kinds of REST APIs, and finally components that wrap existing web technology and make it available as component for Delphi developers. And here you can see results of several visual controls. In this case, you can see a planner here, rich editor, grid, tree view, user interface controls that can be used everywhere, all the targets and all the frameworks. And this is an overview of the many different FNC products that have been created so far. You can find all these products on our website. All products have a fully functional trial version with which you can explore this rich functionality. And so let's now have a look at how we can add FNC in the mix and create Miletus applications that also include FNC components. So now let's bring FNC in the mix. And so here I already prepared this demo. This is a Miletus application, pretty much the same thing, a Miletus application, and I dropped an FNC component on this form. You can see this is the FNC planner, and this component has plenty of properties to control how it looks, behaves, how it presents the data in days, months, weeks, etc. And so in this demo I did not have to add any code because I can already show quite a bit of things out of the box. So when I run this application, it will create a Miletus Windows application. And so we are again in debug mode as our menu is available here. And here you see our planner component. It has some items preset, and as you can see, I can do all the typical operations that you would expect from such a planning tool. And so this is now running in an embedded browser in a native Windows application. When I would choose here, please create a Raspberry Pi application. When I activate this and now build it, application is building. Okay, and that was successful. If we now go on the output folder, so I move to this folder, we can see here the folder where the Raspberry Pi application was generated, and you can see the two files needed to deploy to your Raspberry Pi, and with that you can run this same application directly on your Raspberry Pi. But we will do that in a moment to show you the real application running on a Raspberry Pi, also working with electronic sensors attached to it. All right, and that was FNC. Now let's have a look at what makes the Raspberry Pi target a little bit different from the other native operating systems that you can use, that you can target Miletus applications for. So what makes a Raspberry Pi different? I think this is in the first place, of course, all kinds of electronics accessories that you can attach to the Raspberry Pi. And the Raspberry Pi actually only becomes interesting when you start playing with these electronics accessories connected to it. So to allow you to take advantage of these extensions, we have introduced an extra unit in Miletus, which is the weblib.miletusraspi.pas. And via this unit, extra components become available specifically for the Raspberry Pi that allow you to access different hardware that you can connect to it. And the kinds of hardware that you can connect to it are hardware that interfaces via I2C, SPI, the UART, and also the GPIO. If we have a look at the Raspberry Pi, you can see the different kinds of I/O that are available through the Raspberry Pi 40-pin connector. So it offers out of the box two I2C interfaces, two SPI interfaces. You have 11 exclusive GPIO pins. That means pins that are exclusively used as GPIO. You can also configure more pins as GPIO, but then you will of course need to skip, for example, using some I2C or SPI or UART. And so another way to communicate with external connected hardware is via a UART port. And how can we now access electronic sensors or step motor drivers, etc., that you have connected to your Raspberry Pi via classes, components. And here is, for example, the interface of the component that gives you access to I2C. And as you can see, you can open this I2C port, close it, and read and write to specific addresses on the I2C port. Somewhat similar is what you can do with SPI, which stands for Serial Peripheral Interface. And also here you can open the SPI port, close it, and you can read and write to it. The UART, which is also out of the box in the Raspberry Pi, also the UART you can access with the Miletus Rasberry Pi UART component. You can do all the settings of your COM port through which you want to communicate, open and close it, read and write data to it. And finally, we have the GPIO pins, stands for General Purpose Input Output. That means that on the Raspberry Pi, you can configure each of these GPIO pins as being an output to set a signal to on or off, or also an input, and so you can read the state of some electronic signal via this pin. You can configure each of these GPIO pins to function as an input or an output, which you can do with the GPIO config method. And there is a function to, if your pin is configured as an output, to write to this pin to set the actually the value of this pin to on or off. And you can also read to detect if there is what the state is of the electronic signal connected to this particular pin. For this demo in this webinar, we have chosen the Bosch BMP 280 sensor, which is a sensor that gives you the temperature, the humidity, and also the air pressure. We have chosen this sensor because it has an easy interface, and also because there are different vendors that sell this sensor directly wired, which means that with the wires attached to the sensor, you can directly plug it into the Raspberry Pi connector and start playing with it right away. Otherwise, many other sensors require that you would do some soldering first, and to make it easy for you to allow you to get started right away without much electronics experience, we have specifically chosen this Bosch sensor. So it has an SPI interface. It uses therefore the SPI pins, SDI, SDO, the clock pin, and then also the common ground pin, the CSB pin. And so this is the map of, let's say, registers that this sensor offers, and it is through reading these register values that you will be able to retrieve the temperature, the humidity, and also the air pressure. And so this here, this is from the docs of the BMP 280 sensor. Here you can see the formulas to apply to get the actual temperature, humidity, and air pressure based on the values from the registers that you can read. So basically what we will do is read the register values, apply these formulas, and if we apply them correct, you will get the correct temperature, humidity, and air pressure. Why Bosch forces you to apply these formulas is, well, I think given by how these sensors are internally designed and the electronics that are used for sensing the temperature, humidity, and air pressure. And so let's now have a look at our Raspberry Pi and start playing with our Bosch sensor. Okay, and here it starts to get exciting because we bring all pieces of the puzzle together. As you can see, what I have here is the Raspberry Pi, and connected to the Raspberry Pi here is our Bosch BME 280 sensor. And here I have, with a VNC viewer, I have my access to my Raspberry Pi operating system. And here I have a folder which is a folder on a network drive. And what I will actually do is generate from our Delphi IDE the application and let it generate the output on the network drive. I will pick the generated application, Xcopy deployment to our Raspberry Pi, and then run it from the Raspberry Pi. And with that, we'll be able to play a little bit with the sensor that is connected to our Raspberry Pi. You can see here that it is connected to the SPI pins on the 40-pin connector of the Raspberry Pi. And here actually the little metal box, this is the BME sensor. You will see in a moment that we can influence it a little bit, and with that proof that actually everything is working live here in this environment. Let us go back to the Delphi IDE where I prepared this application. So this is the Miletus application. As you can see in the project manager, it consists in this case of one form, and I have dropped several FNC components on this form. There's two FNC gauges and one FNC chart. And the gauges will be used to show the temperature and the humidity respectively. The chart will be used to show the air pressure in overtime. And here we have our component to access the hardware, the BME 280 sensor. We also have a timer because we will, as you can see, every so much time poll for the new temperature and the new humidity, new air pressure, read it and update the visual controls on the form. And so if we have a look at the code that is used here, you can see that what I'm doing is reading the values from the Raspberry Pi. So at some specific address hex FA, I'm reading a couple of bytes, and then I have separated the mathematical functions that need to apply it to the values that are read from the register in the sensor, and get with this function the actual temperature out of it. And this actual temperature, which is a double value, I use this as a setting for my first temperature gauge. And the second thing is to read the pressure. So I need to read from other registers in the BME sensor, and I have also isolated the mathematical functions to apply to the values, to the register values read, and calculate the actual pressure from it. And with the pressure, I will actually feed the FNC chart and add a point to the chart, to the one of the series, the series that shows the air pressure. I add the point and basically update the chart with the new point that was added. And finally, this sensor also offers humidity. So I'm reading from yet another address, hex FD, two values in this case, 2 bytes, 2 register values. Read them, apply again the formula that Bosch prescribes, to get a real human understandable value for the humidity, a percentage between 0 and 100, and I assign this to the second gauge. And what I do is I stop the timer while these calculations are happening, while also reading from this register is happening, to ensure that if for some reason there is some delay in reading these values, that my timer is not triggered again and does not want to read again while the previous readout was not yet completed. Also interesting to remark here is the use of the await function. This is because the Miletus Rasberry Pi function read buffer is an asynchronous function. So this is the way that internally this works, and that means that the browser reading this cannot immediately return the value. It returns it asynchronously, but by using await we can still write our code in a sequential way even when there are asynchronous functions used with it. So you can see that accessing these registers over I2C in this case is asynchronously, but we have, with using await, still managed to write our code in a sequential way. And so other than that, there is not much happening. Here is the mod functions that are used to calculate these values, but that is basically it. So let's see what is happening when we compile this application. So in my options under TMS WEB Compile, I will specify my output path to be the path which is the network drive. I will make sure that the output is sent to this folder this way. So these are the settings for the project, and that means I have also chosen here as a build target the Raspberry Pi. And so let's build this application now. It is being built here in release mode. And so now I can go to my Raspberry Pi and let's refresh this view. You can now see on my network drive that the two files, the executable and also the desktop shortcut, have been generated. You can see that the executable is 7.2 megabyte, and so let's Xcopy this to our Raspberry Pi desktop and now launch this application from the Raspberry Pi. So this is our application. It is being started, and we can see here that the timer is already running and already read values. We see here that the temperature is 26 degrees and the humidity is about 58%. Air pressure around 1020 hectopascal. To show you, prove you that this is real, this is live, let's now fool our sensor a little bit by manipulating it. So what I will do is touch it, and as I touch it, you can see immediately that the temperature and also the humidity has increased. I release my finger from the sensor, and now we should slowly see values getting back to normal, measuring the room temperature and room humidity. So that shows you how we can here live interact with our sensor and immediately see the effect in our Raspberry Pi application. I do not have with my finger that much control over air pressure. That's why you see in this chart not so much happening. Air pressure is quite constant for now. But this shows you how you can create interesting, I think, Raspberry Pi applications that interact with electronics connected to it. All right, that was an exciting trip into the Raspberry Pi and the electronics connected to it. We only scratched the surface of the possibilities with this. We have done much more with the Raspberry Pi, of which you can see different results. Check our YouTube page where we have videos of other things that we did with the Raspberry Pi and did with Miletus this way. So that brings us to the questions of this webinar. Let us know what you think about it, if you have any additional questions, and of course you can always also reach out to us via email, our support center on our website tmssoftware.com. We look forward to what exciting ideas you have with Delphi in combination with the Raspberry Pi and this Miletus technology. And if you have further ideas to extend the Miletus framework, we would love to be in touch and work on it. Thank you very much for attending this webinar.
Well, that was great. And we have actually got Bruno with us live in our virtual studio. Hi, Bruno.
Hello, Ian. You hear me?
Yeah, we can hear you. You're super loud now as well. That's funny. Yeah, a couple of people say all the video is a bit quiet, but that's fine. In the replay, we'll make sure it isn't. I wanted to just bring this up as well and hold this up because the Raspberry Pi is inside this as well. This is a Raspberry Pi 400. And this is one of the reasons why we've got this session, because I think they're great devices. And, you know, I talk to lots of developers in the conferences and in various social media and things like that. And Raspberry Pi comes up quite a lot. And as far as I'm aware, you're the only person I know who are actually providing components that will allow Delphi to run on the Raspberry Pi. So I was very keen to have this session, and I'm very grateful for you to have done it. And by the sound of it as well, we've got a few people. Joe Carney has said, thank you, excellent. That was about your demonstration as well. And Patrick has put up your Miletus website as well. A very interesting demonstration. If people scan that code, they'll go directly to TMS software website as well, because you do a lot more than this, don't you? You haven't just got Raspberry Pi, just in case people think that's all you do. I mean, do you want to just briefly run through some of the types of components you've got? Because you've got a ton. I personally, my personal favorite is the TMS WEB Core, I have to say. Do you want to speak to that for a few moments?
Yes, I'm also passionate about the WEB Core project because for the fact that enables us Object Pascal developers to use what we are familiar with for so many years, and also offer the ability to create web applications with RED component-based development. I think we have all been spoiled for the past like 28 years with Delphi for building applications with an amazing productivity. And it has been my kind of endeavor for all these years to reach out to the web with the same kind of approach, productivity, etc. And so that has been since 2018 actually, when we did the very first steps in this development, an exciting period for me, and still is, with bringing the Delphi way of developing applications to the web.
Yeah, and I can personally vouch for that. I mean, and this is not vouching on behalf of Embarcadero, because we've got to be a little bit even about all our technology partners, but on a personal level, I'm working on a very large web core product And the brief was to take a desktop Delphi app that has been sold for a number of years. It's a client server product. And they said, make it into a web app. And that's exactly what we did. I'm not the only developer that's worked on it, others as well, but it is a proper web app. It does all the things that the desktop app does, but it's completely based, they can put it on a web server and off it goes. It uses Xdata and Aurelius, which are two more of your products in the background, and it works. We've taken the Delphi code from the desktop product and used it in the web product. There are some differences because it's a web browser. It's not, Windows or something like that. But, absolutely I'm a big fan of your products. I keep saying, if you stop making good products, I'll stop talking about them. It's as simple as that, And obviously, I've got a few friends in your company as well. Holger's messaging me as we speak, and we had Wagner on the other day as well, talking about some stuff as well. Both of your guys that work with you, but the Raspberry Pi stuff. To just get back to that, I personally think it's got some great potential. Most of the Raspberry Pi options that you see for programming are using either the I forget what they're like. Scratch, I think, is their programming language to program the Raspberry Pi, which is kind of a click and drop language intended to teach young students how to program. But I personally think it's good to start off with. But once they start to do some more complicated things, I actually think it's a bad idea, because it then makes them think the way that particular programming language works, rather than coming up with the solution and then working backwards into how they make the language. And I think using Delphi and the Miletus stuff is the right way to go. I think that's a better solution. So very good. We haven't got lots of questions, but we did have a few people just basically saying very pleased with you. As is always the case, once we have the replays of this, there'll be thousands of likes and things like that. So I think it's a good thing. Is there anything else that you want to add before we go away?
I think for all the time we have always tried to listen very good to what your wishes and ideas, etc. are. And actually, it has been for the past more than 25 years always been a driving force between us moving the components forward. So my last words would be one more invitation for the people who get to work with this stuff and have other ideas, more ideas, wishes, dreams for where to bring Delphi. Be in touch, reach out to us. We are always listening, communicating, and as in the past, numerous things that we have developed are a result of communication with customers. I look forward to many more years listening to customer feedback, ideas, suggestions, work on them, and bring them to the Delphi community.
Yeah, I mean, the strength of Rad Studio and Delphi really is that it's component-based development. And I said this in actually my video that came out earlier on, and the one I did at first on the first day. Why work hard? The benefit of a component is that functionality is ready-made for you. Why would you go and write a load of code if you've got someone like TMS who've actually got lots of customers telling them if there's a problem or a bug? Because sometimes, things change. Windows does something with an API and breaks it. But if there's something wrong, the benefit that you have is that you have hundreds of people, or maybe sometimes even thousands of people, telling you that there's some issue. So what happens is that actually debugs that code in a very efficient way for the individual programmer, because there are lots of input to you, and therefore you're responding and fixing that. But that means then that when we take that existing functionality of the component and drop it on, we're not having to create our own novel code. Your component's doing that, and that's the benefit of component-based development. And tech partners like you do it so well, really. you've got so many components. Sometimes it's actually difficult to choose which one because there's so many choices. And I'd rather have that problem than the other way around, where there isn't a solution. So it's great stuff. Okay, well, I appreciate your time, Bruno. Actually, there is someone asking a question. They're saying, with Miletus, what percentage of the framework is native compiled code as opposed to web-based code? I don't think
Okay, that's a good question. Well, for the good understanding, an Miletus application consists of a native shell application. And basically, the functionality of this native shell application is host an embedded browser, because that's where the application is actually, the application that you built is actually running. And an important function, of course, is the bridge between what is being executed in that embedded browser and via the native application, the bridge to operating system functionality. That means that out of your web technology based application running in that embedded browser, you can call operating system functionality, which of course is something that you would never be able to do directly out of a browser because of the secure environment the browser is supposed to offer. So that native shell application is like a fixed code. The size is fixed. And I'm actually at this very moment, I'm trying to get the exact numbers for the demo that I showed here, where the FNC is involved, and where this is embedded in this native shell application. You have seen that the total application size here in this case is around 7 megabytes. So now I'm here actually on my machine trying to figure out if I can see numbers that are more precise. So just a moment.
Sure. And whilst you're looking that up, I'll say as well that the demo that you showed was a very good one, in the sense that it showed you talking to the GPIO pins of the Raspberry Pi, because that's one of the things it does. I know people that are doing so I'm just getting messed about the next session. Things like watering sensors for plants and all sorts of weird things. I think I saw someone even have an earthquake sensor made out of a Raspberry Pi, which is pretty incredible. But with the FNC stuff, it's interesting.
Okay. So I found, meanwhile, exact numbers. So for this case, the native shell application, so the compiled native shell application without any web technology based code that comes with it, is 7 megabytes in the case of the Raspberry Pi, because the sizes are different for different operating systems. In the case of the Raspberry Pi, it's 7 megabytes. That means that this demo with the BME 280 sensor and the FNC chart added to it are approximately adding 300 kilobyte to this application.
Which is absolutely nothing, really. And even on a Raspberry Pi, when you've got these SD cards, because they all come by default with an SD reader, it's really not a problem. You're not taking hundreds and hundreds, put it that way. And the only other question, which I think I know the answer to this, they're saying they'd love to see this for C++ Builder too. Unfortunately, I'm pretty certain that you can't do that. That's right. It relies on a compiler that only does Delphi. So it's not your fault. It's just the technology that's available. I'm sure you'd love to do C++ Builder, but it's just one of those things. I know the answer to that because I've been asked that about WEB Core as well, which is a similar technology. There is a free Pascal compiler and things like that in the background. Okay, and some questions about using this compared to the Arduino. Basically, Arduino is a slightly different device. Boyan Maitov does his Visuino IDE, which does Arduino stuff. The Raspberry Pi and the Arduino are similar, and you get ESP32 devices and things like that for IoT. But no, this is aimed currently at more desktop computer or mini computer type things, whereas an Arduino is more of a smart controller than a computer, and there are some significant differences the way Arduino works. I'm sure
I think the main difference is that the Raspberry Pi actually runs an operating system, which gives you all the things that come with an operating system, including a file system, which is not the case with the Arduino. So as soon as you would want to take advantage of these typical operating system related things, the Raspberry Pi is a natural choice. If it's not needed, and if power concerns, price concerns are important, then the Arduino might be your preferred choice, or even the ESP32.
Yeah, I mean, I've got over on my workbench here, which they can't see because there's the green screen. I've got a number of different devices like that because I like fiddling with things. I'm not as bad as Jim. I never actually plug my brain into a computer. Jim McKeith, my predecessor in developer relations, actually wired himself up in all sorts of bizarre ways. I'm surprised he didn't embed a chip in his arm, because that would have been the next thing, that he'd have some microchip in. But anyway, oh well, thanks a lot, Bruno. It's always a pleasure to talk to you and the other TMS guys as well. You're a great tech partner, and it's nice to be able to support you, and you support us. It's a good relationship, I think, and it's always good to talk to you. So thanks a lot. And
thanks, Ian, for having me here, and thanks for everyone watching for your time. And as always, be in touch when you want to move forward with this Miletus project. We are here. We have the team that is ready to help you.
Scan that code. That takes you directly to the website.